Find the magnitude or length of the following vectors. We've got u is 4 minus 3, it's a two-dimensional vector, and b 4 minus 3, 5, which is a three-dimensional vector. Notice this could be written as 4i minus 3j, and this one could be written as 4i minus 3j plus 5k. Now let's have a look at this GeoGebra app. Okay, it's in 3 dimensions, this GeoGebra app. Okay, so it's in 3 dimensions. Now what we've got here is this vector here. This vector here is the vector 4 minus 3, 5. So we're going to equate that to A, B, C. So the I component is A, the J component is B, and the K component is C. These are the lengths A, B, C. And what we want to do is find the magnitude of the vector. We want to find the length of that line. Okay, let's have a look at that. So let's click. If we see here, we've got that's the I component, the orange bit there. And if I click here, that is the J component. Okay, if we apply a little bit of Pythagoras to that, so we're just going to look in 2 dimensions to begin with. So we're just going to look on this plane here, this XY plane. This is the XY plane. If I click on there and draw a square there, and then that's going to be 16, 4 times 4, and a square there, that's going to be 3 times 3, which is 9. Then if we click on that one there, alright, that's going to be 25. In fact, if I move this around a bit, you can see that much clearer there. You can see that's a very clear application of Pythagoras' theorem. Alright, so in order to find the length of a 2-dimensional vector, which is the green one here, all I need to do is square the I component and the J component, add them together, and that will give me the same length area as that square, and then take the square root, and that gives me the length of that vector. Okay, so in order to find the magnitude of a 2-dimensional vector, AI plus BJ, it's just the square root of A squared plus B squared, which in this case is going to be 4 squared plus minus 3 all squared. Notice the minus 3 is in brackets. So let's just go back to this. So u is AB, the magnitude is you do A squared plus B squared. So u will be is 4 minus 3. Therefore the magnitude of u, and the symbol for magnitude is 2 straight lines. It's going to be the square root of 4 squared plus minus 3 squared. Make sure you put that minus 3 in brackets. So that's going to be 16 plus 9, and the reason for putting it in brackets, if not, you'll take 16, take away 9, which is not going to be correct, which is the square root of 25, which is 5 units. Now in 3 dimensions, that's a little bit more complicated. So let's click to add this square down here. So we're now going to find the length of this vector here, this one here. Now this blue square on this side, okay, is going to be the same as the blue square here. Okay, so I'm just going to deselect those. We're now going to look at it in 3 dimensions. Okay, and I'm going to add in the K component. So my vector goes along I, along 4. We already know that's the square root of A squared plus B squared. A squared plus B squared is that length. It's the same as that square there. So we're just looking at a different plane now. Okay, in order to find, we need to find the length of the square on that side. So that's going to be that one there, which also is 5, so it's 25 times 25. And we can see that will be the same as that one. Okay, so if we put it like that, we'll be able to see it much more clearer. Okay, so in order to find the length of a vector in 3D, we find the magnitude of A squared plus B squared, the I and the J B components, which gives me the area of that square. So this is square root, the area of this square is A squared plus B squared. And then I need to add to it the area of this squared, so this will be C, so it's CK. So it's going to be 5 squared. Okay, 25 to 25 is 50. In order to find the length, we need to take the square root of this square and get the answer of it's 2 root 5 or 7.07, or the square root of 50. Okay, so let's just click them all, put them all back in. So what we do is we find that's a 2-dimensional, and then we turn it around to make it 3-dimensional, and we end up with this formula for finding the magnitude. So it's just one more thing, you just add c squared and then take the square root of it. Okay, this applet I will attach to the notes of the video for you. So going back to this, if V is A, B, C, then the magnitude with two straight lines, that means find the magnitude, the length is square root of A squared plus B squared plus C squared. So V is 4 minus 3, 5. Substituting, the magnitude will be 4 squared plus minus 3 all squared plus 5 squared. Put the minus 3 into brackets. So it's going to be the square root of 16 plus 9 plus 25, which gives you the square root of 50, which is 2 times 25. Square root of 2 times 25, the square root of 25 is 5, so that gives you 5 times root 2, or if you work that on your calculator, 7.07 units to 3 significant figures. Okay, so we'll just go back to the applet again. So to do 2 dimensions, you just look at it like that. This is an XY plane, the grey bit here, so it's going to be that one squared plus that length squared plus that length squared will give me that length squared. So the green vector there is a 2-dimensional vector, okay? But if it's in 3 dimensions, then you need to take that square and look at it this way round, and remembering that is A squared plus B squared, okay, and then add C squared, and then take the that will give you that area, and then take the square root of that, it will give you the length of that. Hence we end up with this formula here, which is very, very important for finding the magnitude of a vector in 3D. Okay, I hope this has been useful. Again, I would say I'll put this applet into the notes of the video. Thank you very much for watching, and I hope you've understood.